Information on black holes is limited, though numerous schools of theory exist. No one has yet discovered a black hole for certain. Scientists think black holes exist not because they can see them, but because of the impact they have on the space around them. Astronomers refer to these objects simply as black holes, in spite of the uncertainty. A black hole is a super-dense object that has an intense gravitational pull. There are two parts to a black hole, a singularity and an event horizon. If you were to take a slice of a black hole right through its center, it would look like this. The gravitational force is strong near a black hole because all of the black hole's matter is concentrated at a single point in its center. The point at the center of a black hole is called a singularity. Singularities are believed to be much smaller than an atom's nucleus. If the mass of a compact object is found to be very large, then there is no kind of object scientists know about that it could be other than a black hole. In other words, where there is smoke, there is fire. When two things occur together frequently, it is possible to assume there is a direct or causative relationship between them, but it is also possible that there are other factors. The surface of a black hole is known as the event horizon. This is not a normal surface or physical boundary you can see or touch. Rather, the event horizon is the point of no return for anything that crosses it. At the event horizon, the pull of gravity becomes infinitely strong. When describing the size of a black hole, scientists are referring to the size of the event horizon. The more mass a singularity has, the larger the event horizon. Within a certain distance of the singularity, the gravitational pull is so strong that nothing, not even light, can escape. Therefore, an observer, no matter how close to the event horizon, will see nothing. So scientists can't just look for black holes. However, scientists can observe the gravitational effects on other objects nearby. Like puzzle pieces, we know what a missing piece is shaped like based on having all the surrounding pieces in place. As interstellar matter, such as gas, dust, or even entire stars, are sucked into the black hole, the material is accelerated and heated to very high temperatures. This process is known as accretion. As the particles speed up and heat up, this in turn results in the emissions of X-rays, gamma rays, and other forms of electromagnetic radiation. This series of 4 illustrations shows a yellow star that travels too close to a black hole in the center of a galaxy. As it nears, the star is stretched by gravitational forces from the black hole and is quickly torn apart. Most of the yellow gaseous debris from the star escapes the black hole. However, a small amount of material is captured by the black hole and forms a rotating disk of gas. X-rays are emitted as the gas in the disk is heated, as shown by the blue color, and is gradually swallowed by the black hole, eventually emptying the disk. Black holes, tell scientists, the relativistic theory of gravity and space-time provided by Einstein's general relativity is fundamentally correct. When scientists use these equations to study cosmology, the answers make sense. Black holes also tell scientists the universe can hide much of its matter in a way that still contributes to the total mass of the universe, but may not contribute to the abundance of certain primordial elements such as hydrogen, oxygen, and helium. One of the most baffling mysteries in science is that 96% of matter in the universe required to explain its composition and structure is dark matter that is unseen and unaccounted for. It's simply missing. Though scientists do not know what dark matter is, they do know what can be seen constitutes only 4% of all matter. Black holes are just one possibility that may account for some of the dark matter of the universe. So go out on a clear night and gaze upwards to the skies. Enjoy the wonder of the stars, moon, and planets. Then take a moment to contemplate the vast universe we cannot see, that we can only guess is out there. As Carl Sagan once said, "Somewhere, something incredible is waiting to be known."